Good morning to our participants from the Caribbean and good afternoon to our participants from Africa. Thank you for joining our webinar on the impact to climate tools. My name is Rand Abajamiya and I will be facilitating this webinar. Our presentations today will be held by climate analytics researchers, namely in the following order of their presentations. Marina Andreevich, a climate economist focusing on barriers to adaptation. Peter Pfleidere, a climate physicist specialized on extreme weather impacts. Emily Theokritov, an environmental engineer with a focus on adaptation and vulnerability. And Dr. Quentin Lejeune, a climate scientist with a focus on land-climate interaction. I would like to draw your attention that this webinar is being held in English. If you would like to join our webinar in French, please note that it will take place in 2 days' time. On September 18th at the same time, 10 a.m. Eastern Standard Time and 2 p.m. Greenwich Mean Time. Please be aware that during the whole webinar, all participants are automatically muted to avoid background noises. Please do not hesitate to ask any questions you may have on the tools, its functionalities, or applicability. Simply note your question in the Q&A section at any time during the webinar. You can find the Q&A section at the bottom of the webinar window on your screen. We will revisit the questions after all the tools have been presented. We will try our best to deal with all your questions. However, we will answer via email those that cannot be answered during the webinar due to time restrictions. The webinar is being recorded. We will share the link to the recording afterwards in a follow-up email. After the webinar has ended, you will be asked to fill a questionnaire. We highly appreciate your feedback. I would like to introduce you to the Impact Project. The tools being shown today were mainly developed under the Impact Project. It's a cross-cutting, multifaceted project that aims to strengthen capacities in small islands, developing states, and least developing countries to co-develop scientific outputs and knowledge products, such as the climate tools discussed in this webinar. The project also supports relevant actors to make use of the outputs in the development and project as started in 2016 and currently in prospect of extension. It is funded by the German Ministry for Environment, Nature Conservation and Nuclear Safety. The webinar today is designed to give you hands-on experience on how to use the climate tools, their functionalities, and background data. The structure of the webinar, we will first present the cost of inaction tool, a tool that provides the means to measure additional economic damages for both SIDS and LDCs under 3 degrees of warming compared to 1.5 degree of warming. Afterwards, we will present the local sea level rise. As its name suggests, the tool allows its user to see different projections for sea level rise at different levels of warming across the globe. This will be followed by a presentation on Adaptation Map, which provides an overview of adaptation actions being taken at the country level in the Caribbean and in West Africa. We will proceed with the final 2 tools in our webinar, RegioCrop, which allows users to access crop yields projections for all countries in Africa, and last but not least, RegioClim, which is a similar tool providing climate projections for all African countries. Without further ado, we will start now with our first presentations on cost of inaction tool.
Thank you, Ren, for this nice introduction. I will start, my name is Marina. I will start with introducing you to one of our latest tools, which is called Costs of Inaction. You can easily find the tool by going on our homepage of climateanalytics.org, where you will find a section called Tools, in which you will easily find the costs of inaction right here. In this tool, we measure economic damages as represented by one of the most common measures, or the gross domestic product, which is the monetary value of all goods and services produced and sold in an economy during 1 year. On this map, we're using the method developed by Marshall Berkey and colleagues from Stanford University, who have published several papers in journals like Nature, Science, and PNAS, in which they analyze changes in temperature and couple this with changes in economic output for more than 160 countries for over 5 decades. The estimates from this analysis are then combined with projections of future climate change from global climate models and projections of how countries' economies might develop without any additional climate change. We have somewhat modified this analysis to show the estimates specifically for the two warming targets, namely the 1.5 degrees and 3 degrees of additional warming, which is where we're basically going if the countries retain their current pledges under their NDCs. So the tool is rather straightforward. It shows two types of information. The first one on the map is the percentage difference in GDP per capita between the two temperature pathways, so between 3-degree pathway and 1.5 degrees. What you can see on the map that's color coded by the legend, and for two time periods. So first for 2050 and then for the end of the century. What you see on this map is what additional reduction in GDP would happen if the warming went to 3 degrees as opposed to 1.5. Here, the countries that are in gray, this means that the difference is lower than 5% between the two levels of warming, and then the darker the color becomes on the spectrum from yellow to red indicates higher reduction. This overview is available for the two time periods, as I said, and the map, or the colors of the map, change quite drastically the further we go into the century, with sizable reductions in GDP between 3 degrees and 1.5 for almost all of our here represented small island developing states and least developed countries. For individual countries, there are two ways to obtain a bar graph that you can see in the bottom right corner here. So either by zooming in onto the map and then picking a country, for instance, Senegal. Here you'll obtain similar but slightly different piece of information than what's on the map. So here we show percentage difference between GDP per capita under 1.5 degree pathway and GDP under no further climate change scenario. And then the same for a 3-degree pathway. These are color coded blue for 1.5 degrees and red for 3 degrees, and shown for mid-century and end of the century. Another way to get to a bar graph or to see all the countries available here is to go down the drop down menu here. So for instance, we can go to Trinidad and Tobago and see the countries here, or go back and look maybe at another West African country. Sometimes it takes a bit to load. Here we have it for Burkina Faso. You can click on the map and save the image if you wish to download it. With this, I would end our costs of inaction tool, and I will take all your questions at the end. Thank you. I will pass on the floor to my colleague, Peter.
Hello, thanks for the introduction, Marina. I'm Peter, and I'm going to talk about this local sea level rise tool. Which is here. So this tool shows projection for sea level rise, and here at the local scale. And why would we be interested in local projection of sea level rise? So there's different processes that contribute to sea level rise, and some of them is the meltdown of ice sheets in Antarctica and Greenland, and also of glaciers. But there's also important dynamical processes as oceanic processes, currents, and wind fields that affect the sea level rise on the local levels. And then there are some non-climatic effects as the construction and groundwater extraction that would also lead to local effects in sea level rise. So here on this tool, we have projections that we obtained from Robert Kopp et al. And his colleague DJ Rasmussen for different tide gauge stations. So in these tide gauge stations, sea level rise is monitored, and using these observations, they made projections for the future. In principle, there's two ways as for the last tool to access these projections. One is to click on the map, and one would be to use the search bar here. So the main information you would get from this graph would be the graph which is shown in the top right corner. I'm confused now why there's this. Okay, let's just keep this graph here. So there's this one graph which is showing the whole information which you would get for one station. And this is on the x-axis, you have the years. So there's a time axis on the x-axis, and then you have the sea level rise in centimeters on the y-axis. And this is shown for three different scenarios. One which is a roughly Paris-compatible scenario, and then two scenarios which have warming greater than 1.5 degrees, one with 2.5 degrees at the end of the century, and one with 4 degrees at the end of the century. And for each scenario, the ensemble mean or the mean projection is shown by a solid line, and then there's some uncertainty estimates shown by the shading. You can check this graph and download it also, but you can also see the numbers from this graph in a table down here. So the color coding are exactly the same for the three scenarios. Then there is some additional information for those who are even more interested, and you can check it at the bottom of the website. So here you can check the different contributions to sea level rise and the contributions to the variance in the projection. So here you have the different components as the Antarctic and Greenland ice sheet in red and in cyan, and then there's the oceanic processes, glacier and ice caps, and finally land water storage and background effects. And for the different stations, this might look quite different. Finally, you will see that actually there's not that many stations, tide gauge stations in all regions. For instance, over West Africa, we don't have so many stations. So here you could also access gridded data. This is available around the whole coast, but we recommend to use the station data where it is available, because these grid projections are just interpolations between the stations, and no detailed information about the coastline and the processes happening at the coast are available. So they're much rougher estimates of how the projected sea level would look like in these regions. And with this, I would hand over to Emily, who's going to show you the next tool.
So hello, and thank you, Peter. So as you just said, I'm Emily Theokritov, and today I'm going to take you through the adaptation map. So the adaptation map that you can see here on the screen is a library of policies, strategies, programs, and projects that bring together documents from 11 countries in West Africa and member states of the Caribbean community. And the countries included are the ones marked in red here on the map. And the documents collected were published from 2010 onwards. The main purpose of this map is to foster inter-regional learning on adaptation action. So it's to be able to look at what is being done within a country, within a region, but also across regions. So in this case, between the Caribbean and West Africa. So there are two ways to search for this document. The first one is to look at the adaptation actions per country. So you can either directly just click on the country on the map or select from this drop-down list. So let's look at the documents for Mali, for example. Here you have the list of documents available for the country. And for each document, so you have a hyperlink to be able to directly access the document. You have the sectors it includes, and then there's a very short description of the aims and objectives of this document. The second way to look at the documents would be to do a sectoral search. So let's say you're interested to look at all the adaptation action that is being done in the field of agriculture. You would click on agriculture here, and then I'm interested in all the countries that are available. And here you can see a list of all the agricultural adaptation actions taking place in the selected countries. One other nice function of this map is simply just by hovering over the countries, you can see which sectors are included and most represented, which allows a quick comparison. There's this home button that always brings you back to the very start of the web page. For West African documents, there's a French version of the website that is available for any French-speaking colleagues. And on a final note, this is not a web page that is being put up to date regularly, so it's not an exhaustive source of all adaptation actions happening. It's actually documents that were collected within the frame of a study, and we think it's very useful in informing different adaptation actions happening regionally. I will pass on back to my colleague Peter, who will speak about the next tool.
Hello again. So here I'm Peter again, and I'm talking about RegioClim now. So this is a tool which is supposed to give you basic climate information for African countries. And this is an interactive tool, so there's a lot of option on the sideline here where you can adjust and search for different topics in climate sectors or climate information you might be interested in. And yeah, so the first thing you might want to select would be the country. So here there's a top drop-down menu. And then you have the indicators here, which might be the most interesting information or the two most important options you might want to check. And then if you have selected these two, there are 4 graphics which are shown as a default page in the beginning. And the first one would be the left top plot, which is the reference period map, which is showing in this case now the precipitation over a reference period, which is here 1986 to 2005 for Benin in this case. So this is data from reanalysis, EMBI. Then on the right side now, you have the climate projections for the 2040s as compared to the reference period. And this is also shown, now in precipitation changes, and bluish colors would mean an increase in precipitation, reddish colors a decrease. And then you see that there's a lot of gray grid cells. And these are now the grid cells where our ensemble doesn't agree on the sign of change. So one thing we deliberately didn't give as an option here in this tool is the choice of the scenarios and the models which are shown in the projections, because we thought that this might be a tool that people who are not so familiar with all these climate projections and the climate models might want to use. And so here you have a pre-selection of a combination of 4 regional climate models, which are forced with 4 different global climate models, and only RCP 4.5 scenario. So this is an emission scenario which is neither reaching the Paris Agreement, but it's also not the worst case scenario. So it's something like in middle of the way or of the different climate scenarios which are available. And in the bottom, you have two other plots. So one is a country average over time. So the x-axis is the time axis, and then you also have precipitation. And you see how this would evolve for the country mean. And on the right side, you have the annual cycle, which is something really important also. So here you see in which month there is a lot of precipitation. And then in the last plot here, you see the differences for each month. So now let me come to the options you have here on the left side. So one of the most interesting thing might be that you are able to choose a season or the finest season which you want to study. So you might be interested in June precipitation because it's important for some kind of agricultural processes. And then you see here, when you select June, then these two plots change, the top right and the bottom left plot. And here you see the map for the differences or the projected changes in June precipitation. And you see that in some regions there seems to be a strong decrease. Another thing you can check is you can select the region. So here, for example, I would select Kufo. And as I said, so this is an interactive tool and there's a lot of options. So the data is stored on a server and the plots are created depending on what you select here. So sometimes it takes some time. And now you would have here this little tiny region, which is around here. And you have the average for this region in the precipitation of June. So this is some very specific information here. You would also get the warning that this is a small region and you might want to merge some regions around it to have a more robust climate signal. So this whole tool is also available in French for the French-speaking colleagues. And you can download all the graphics as PDF or PNG. And the last thing you can choose would be a different time for the projection. So you can either write in a period here, or you can look at the projections for different global warming levels. So for instance, here you would have a reference period, and now you look how would be the difference if we look at a 2-degree world above pre-industrial or 1.5 degree world above pre-industrial. Finally, if you're interested in the details of the tool, there's a quite extensive documentation documenting all the methods which are used to create the graphs, and also the models which are used, the scenarios, and the bias correction technique which is applied to the climate projections to make it more usable for sectoral applications. And with this, I'm handing over to Quentin, which is going to present the next tool.
Thanks, Peter, and good afternoon, everybody, or good morning. Just before I start, my name is Quentin Lejeune, and I will present you a tool called RegioCrop. But I just wanted to remind you that you have the possibility to ask questions through the chat software, and that we'll be happy to answer those just after my presentation. So I will now start with this one. So this is a tool called RegioCrop, which, as the name suggests, is similar to RegioClim that Peter has just presented, except that it presents projections for crop yields instead of projections for climate indices. So we just, let me just click through the website to explain a bit what it's about. So this is a landing page, and you see immediately 3 maps here. And some of you will have recognized Benin, but actually you could select any African country from this drop-down list here, just as for RegioClim actually. So you could see like any African country here. So let's say, for example, we look at Uganda, and then let's have a closer look at the maps that it shows. So you can see here the map on the left is actually showing the yield for maize in ton per hectare per year in Uganda for year approximately 2000, as simulated by 6 global graded crop models that participated in the project called ISIMIP. ISIMIP standing for Intersectoral Impact Model Intercomparison Project. And this is a project that gathers a lot of impact models, including crop models that actually run a coordinated set of experiments to look at the impacts of climate change on crop yields. And they follow the same experimental protocol. That means that their results are actually directly comparable. This is what we actually show the results of the mean results for these 6 global graded crop models here. If you want to know more about ISIMIP, you can click here. That gives you information on the fast track round of simulations, because ISIMIP is organized in round of simulations, and we show here the projections from the round of simulation called fast track. So you can just click here to get more information. And I was just saying, so we show the result from 6 global graded crop models. And each of these crop models is actually driven by the outputs of global climate models, because they simulate the impacts of climate change on crop yield. And these global climate models that provide input data for the global graded crop models are actually from a project called CIMIP5, so the coupled model intercomparison project, the 5th phase of this project. CIMIP5 models being the models that were used for the 5th assessment report of the IPCC. And the crop models follow, so get input from these global climate models from CIMIP5 that were simulating climate change according to the greenhouse gas emission scenario called OCP 8.5. So as I said, we have 6 global graded crop models driven by the outputs of 5 global climate models. That makes 30 simulations in total. And here on the map, on the left, we show the results for the mean of these 30 simulations, so this ensemble mean. So it shows the yields of maize in ton per hectare per year for approximately year 2000 for all these simulations I talked about, on average over 20 years, centered over 2000. You see the scale on the right. But this is for maize, but you can actually also select other crop types, and you have rice, wheat, and soy. So you can select soy, for example, and the map here would only show you the yield for the chosen crop, where this crop was actually grown around 2000, according to the data set we got access to. Otherwise, the pixels are lit in white. So now let's have a look at the map in the middle. So let's go back to maize for that. The map in the middle shows you by how much the yield change for global warming level of 1.5 degrees above pre-industrial times in comparison to this map here. So basically, yellow would mean little change, so maybe between -5 and +5%. Orange and red would indicate a decrease in yield, and green would indicate an increase in yield. And this is according to the multi-model ensemble median. So, and the ensemble being, again, this ensemble of 30 simulations. Here, the gray cells indicate actually where the models do not agree on the sign of change. So here, basically, this picture shows you that overall for global warming plus 1.5 degrees above pre-industrial times, the yield in maize would decrease about, over significant parts of the country. In Uganda, in some of the regions, it's rather little change, so maybe slightly positive or slightly negative. But over many areas as well, models do not agree on the sign of a change. But overall, the picture is rather indicating the rather negative impacts of climate change on yields for maize for global warming level of 1.5. And you can try this for other global warming level. You can select +1 degree, and in comparison, we could select after that +3 degrees, and you really see that these negative impacts are actually amplifying. Yeah. So we can also look at the picture for rice and soy, which is quite different actually. So if you look at soy, you see rather grid cells, meaning little agreement among models about what will happen, but still maybe overall rather positive results. And you observe the same for rice. So that's maybe a message to take from this simulations. And let's go back to maize to have a look at the last map here on the right-hand side, which basically shows you what happens to yield if one would apply irrigation everywhere where it's not implemented yet according to this map. And this is important to note here. This is assuming that there is enough water available. And obviously this kind of map can only be informative if one keeps in mind this limitation that this just reflects the fact of a case where there would be enough water available. So the map here was produced showing crop yield at around 2000, considering the existing irrigation equipment around 2000. Here, this assumption wasn't changed, meaning it shows actually change in maize yields if irrigation equipment isn't changed. And here, what would happen if on top of that, one would implement irrigation everywhere where it's not implemented yet. And you see rather a positive impact, meaning that probably the crops were not getting enough water in this case, and this can be somehow alleviated if irrigation is implemented. So back to the methods a bit. So the crop models I said we used here are driven by simplified global climate models, and the warming levels are selected with the outputs of these global climate models using 20-year averages. You can download all the images as PDF here. And if you scroll down a bit, you have a table which summarizes the results of these maps here, showing for each crop type that is grown in the country, the harvested area around 2000, and the change in average yield on average of the country for different global warming levels. This number would be the multi-model ensemble median, and this would be the first and third quartiles on of the 30 simulations I mentioned before. If you scroll down even further, you would see a result from only 2 global gridded crop models, but 2 specific models that actually included another set of crop types here: sunflower, sugarcane, peas, millet, groundnut, beans, cotton, sorghum, and cassava. And so only 2 models included those, so these results are less robust than the ones I presented above, but still can be very important, especially for Africa, where because this crop is especially grown in Africa. And basically this table functions the same as the one above. You can download these tables if you click on the button here. You can also access to more extensive documentation about the website by clicking here. Here you get access to some information about the website. And last but not least, here you have the possibility to get access to a French version of the website. So that's it from my side. I will hand back to Rent.
Thank you, Quentin. And thank you for your questions. We have received a few questions that we would like to go through them now. Please be aware that due to time restrictions, we may not be able to answer all your questions. Nevertheless, unanswered questions will be answered by email after the webinar. So in the order of the tools presented, we will start with questions related to the cost of inaction tool.
Thank you, Ren. This is Marina speaking again. Thank you for your relevant questions. I think the questions that we'll answer now are clarification questions that might be interesting for everyone. So for our cost of inaction tool, the first question was, what is the reference period? So what is the reference period for that we're comparing the GDP in the future against? And the reference period is 2000 to 2010. Then the second question asked whether extreme events are accounted for in this analysis. And the answer to this is no, unfortunately, even though we are very well aware that extreme events have a high impact on economies and therefore GDP. In this model, GDP is a function of temperature. So it only takes into account increase in temperature, but not the associated extreme events that might follow. Another question asks why we only show a selected number of countries. So we're on the map, we're showing small island developing states and least developed countries because this is actually the focus of the impact project. So we're highlighting the damages experienced by these countries. That would be it from my end, and I will pass on the microphone to my colleague Peter, who will answer questions about the local sea level rise tool.
Hello, so here's Peter again, and there were some questions about the local sea level rise tool. So the first question would be, how far is the projection for one station applicable? For example, if I have a project 50 kilometers down the coast, is the projection still relevant? In other words, how local are the projections? So this is a very good question. I think it's an interesting one. And as I said, so these projections for the stations are based on single tide gauge stations, and they incorporate very specific processes, which might be very specific for the bay or the region where the station is. So if the coast looks quite similar, even 50 kilometers down the coast, it might be similar projection. But in principle, yeah, one has to be quite careful with this. But one good thing is also that you can check with these additional information here, you can check how big the contributions from the background effect and land water storage effects are. And in most cases, the dominant effects are the Antarctic and the Greenland ice sheets and oceanic processes as shown here. So in this case, you would see that around in this area, at least, this is dominated by large scale effects, and you might be safe by using it also for a different location, but with caution. And then another question was, how did you calculate the gridded sea level projections? Is this interpolated? As I mentioned earlier, so we got the data from DJ Rasmussen and Robert Kopp. And in their study, they indeed did an interpolation exercise to get some projections around the coast for all locations. And this is interpolated and with some assumptions of the oceanic processes and the atmosphere dynamics for the regions. And this would be it for the sea level tool. And now Emily might answer some questions.
Hello, here's Emily again. So for the adaptation map, we got one question, and it's regarding the methodology and what was the inclusion criteria for the documents. So we scanned ministerial websites and multilateral and public funders and bilateral public funders, the website, and the cutoff year was 2010. And we made the decision not to include domestically funded projects because it would have been too hard to keep track of. And yeah, these documents, they were collected as part of a specific study, and a paper was published from this. So if you can have a look at it, it was published in July 2019 in Regional Environmental Change. The name of the document is Climate Change Adaptation Planning in Practice, Insights from the Caribbean. This was for the documents for the Caribbean. It might be of interest to you as well. So that was that for the adaptation map. And now I hand over again to Peter, who will answer RegioClim questions.
Hello again. Thanks for the interest. So there are some questions for RegioClim as well. And the first question was how to access the projection data behind the tool. And I'm happy about these questions because I forgot to mention it, that there is a download button here. And when clicking on this, you would get all the data which was necessary to create the graphics on the website in a netcdf format, which is a typical format for climate data, and also the country averages and the annual cycle would be available as a CSV table. And you would always just get a small portion, which would be easy to download here. If I would click now, I would get the data for Benin and temperature. If I choose some other indicator, a different country, I can click again to get the respective data. Then another question would be for the tools like RegioCrop and RegioClimate, how would the country get their data into this program if it's not already available? So here, unfortunately, I have to say that we wouldn't include new data in here. So for RegioClim, we use the same projections for all countries, and the reanalysis also the same data set for all countries. And I guess we don't want to change this. And so if in a different country would have different projections or also observations that I would want to include to produce similar graphics, you can download the Python scripts for all the tool, for the whole tool, and also for creating these graphics to create similar maps and plots for the data you want to use. But we wouldn't include new data for the website, at least at this stage. And then there's a different question. Can you also select different scenarios, maybe RCP 8.5? So we chose to restrict ourselves to only one scenario, because in this tool, anyways, one has to be careful with these precipitation projections, especially for single countries. And until mid-century, all these scenarios might be quite similar. And here, I think the most information or the most important information would be the sign of the trend and in which region you would have an increase or decrease in precipitation. Then the differences between the scenarios might not be something you want to take out of such a tool. What we included, however, is these future warming levels. So instead of having different scenarios, you can compare with this 2-degree warming level and the 1.5-degree warming level to give an idea of how additional warming would change the projections. So that's for RegioClim. And now I'm handing over to Quentin for the questions for RegioCrop.
Hello again, that's Quentin here. So we got a lot of questions for RegioCrop, so I won't be able to answer all of them, unfortunately, but okay, let me give it a go. So we received a question from a participant asking where the gray colors on the projected change in yield related to 2000 means. So let me show those. So this question is referring to this map here, showing the change in yield according to the crop model simulations for global warming, in that case of +3 degrees, for maize in that case, for Uganda, compared to this 2000 map. And gray would indicate here, as shown in the legends, grid cells where the models do not agree in the sign of change or shown in gray. So here you get your answer. So it's basically the models, there's uncertainty, there is too much spread amongst the model simulations to be able to be conclusive. So you prefer to show the results in gray here. And the second question was, would be useful to have a comment actually that saying that it would be useful to have example for the Caribbean. and Caribbean crops included such as sugarcane, cocoa, and coffee. Indeed, it would be very useful, I'm sure about that, but just we have two limitations here, and they both arise from the technical capabilities of the crop models that were used. One is because all these crop models, they have in common to have these 4 crop types: maize, rice, soy, wheat, and only 2 of them, as I said in the end, actually have these other crops that are also grown. For example, in Africa, you have actually sugarcane here, as you can see, and unfortunately not cocoa, not coffee. And the reason why we don't show projections for the Caribbean is, okay, there are 2 reasons. One is that it was this project, this website was actually demand driven, so it was developed to answer the demand for arising from Africa. And the second one is that the crop models that we use here, you can see the resolution here by the size of the pixel. They have actually a resolution of 0.5 degrees. So it's hard to cover the Caribbean countries with models of that resolution. That's unfortunate, but the technical capabilities are here, unfortunately, create these limitations for the Caribbean. So I will stop answering the questions here, and you can always reach out to us afterwards by email if you have any questions, and we will answer those by email, I think. And over to Rand, we will wrap up. Thanks.
Thank you for tuning in so far. We have reached the end of our webinar. Thank you for taking the time to join us today and for sharing your thoughts on the tools. We had about 50 participants connected from the 2 different regions, the Caribbean and Africa. We really thank you for joining. We will share the recording of the webinar later and answer the rest of your questions by email. We would also highly appreciate your feedback on the webinar and the impact tools. If you would like to provide feedback, you can also do by filling out the evaluation form, which will show up on your screen after the webinar. In your browser, a window will pop up. Please make sure to click continue and answer our brief questionnaire. Please note also that it will take a few seconds before the feedback window will show up. So please be sure not to close the webinar window. The questionnaire will only take about 3 minutes of your time maximum. A special thank you to our presenters, Quentin, Peter, Marina, and Emily. And thank you again for participating in this webinar. We look forward to your feedback. Thank you.